The producers and distributors of Tech AV training programs welcome you to the third module in the series AC and DC Machine Fundamentals. This series of programs has been designed to help you understand the basic operating principles of both AC and DC motors and generators. In this module, we shall overview the DC machine, and you will learn about the key components and their functions, the operating principles of a motor and generator, and basic electrical and mechanical test procedures. As a motor, the DC machine is most suited to driving a load when it is required to control the speed of the load, for example, in lifting and traction machinery. Likewise, as a generator, the machine will produce a direct current output depending on its speed and excitation. In its most basic form, a DC machine consists of the following key parts, namely a rotating part called the armature, a stationary part called the stator, which contains the yoke, the poles and field windings, two end shields fitted with bearings which support the armature, and a set of brushes held in position by brush holders, collectively called brush rigging. Let's discuss the construction and function of each of these parts in detail. We begin with the armature. A typical armature incorporates the following components, namely a core comprising a number of sheets of high-grade electrical steel called laminations, which are pressed onto a steel shaft. Next, the armature windings, which consist of a number of evenly distributed coils of copper wire which are wound into the slots in the core. The ends of the armature coils are connected to the commutator, which is attached to the end of the shaft. The commutator consists of a number of copper bars or segments, which are insulated from each other and the shaft. Next, the brush rigging. On all DC motors or generators, current must be conducted to or from the armature windings via the commutator. This is achieved by a set or sets of carbon brushes which ride on the commutator. Finally, the armature shaft. One end, called the drive end, is used to transmit power to the load, and the opposite end is called the non-drive end, which generally supports a cooling fan. We move on to the static part of the machine. It is composed of a number of high-resistance steel plates called laminations, which are bolted together and pressed into either an aluminium or iron frame. Coils of copper wire are fitted to the core, forming north and south poles when direct current is connected to them. The main poles produce the main magnetic field, and the interpoles produce a magnetic field which counters the effects of armature reaction. After the break, we will explain the basic operating principles of a DC motor.